Tintatis. The Burj Khalifa rises 828 meters above Dubai, a single tower built to dominate a skyline. Saudi Arabia.
The Burj Khalifa rises 828 meters above Dubai, a single tower built to dominate a skyline. Saudi Arabia proposed something far larger in a completely different direction, a city that would run 170 kilometers through the desert, with buildings 500 meters high and only 200 meters wide. Then the numbers began moving. The original vision called for millions of residents, but by 2030 the reported target had fallen to fewer than 300,000, with only 2.4 kilometers expected to be completed by that date. Engineers haven't declared the structure unsafe, and there is no evidence that the line is on the verge of collapse. The problem is different. The scale, cost and schedule have repeatedly been reassessed. This is the line. And here's what nobody tells you about how a project this large can become difficult long before its engineering is finished. The line exists because Saudi Arabia wanted to build something that could represent its economic future after oil. NEOM was announced in 2017 as a major part of Crown Prince Mohammed bin Salman's Vision 2030 program, and the line became its most recognizable piece. The brief was almost the opposite of a conventional city: no roads, no conventional cars, high-speed transit, renewable energy, dense development, and a dramatically smaller footprint. The client is NEOM, owned by Saudi Arabia's Public Investment Fund. For the first phase of the line, NEOM appointed Delugin Meisel Associated Architects, Gensler and Mott MacDonald for urban design, planning and infrastructure design, while Atkins Realis, Jacobs and Parsons have served as major delivery partners. The motive wasn't engineering for engineering's sake. It was economic transformation, international visibility, and a new model for urban development. And on paper, the specification is extraordinary. The line is planned as a 170-kilometer linear development, 500 meters high and just 200 meters wide. NEOM says the completed city would accommodate up to 9 million people on a footprint of only 34 square kilometers, while preserving 95% of the surrounding land. It is designed without conventional streets or cars, with high-speed transportation intended to connect the length of the development. Parsons currently describes the estimated project value at roughly $100 billion to $200 billion. That's important because the often repeated $100 billion figure is not a final audited price for the entire completed city. It's an estimate for the development as presently described by one of its major delivery partners. And then the engineers started doing the math. The unusual part isn't simply making a 500-meter building. The unusual part is repeating that enormous structure over 170 kilometers while integrating foundations, transport, utilities, water, energy and daily life into one continuous urban system. Let's talk about what happens structurally when you turn a city into a wall. In a normal city, buildings are separated. Each tower has its own foundation, utilities, elevators, and maintenance systems. Roads and infrastructure can route around them. The line removes much of that separation. Its concept concentrates enormous quantities of structure and infrastructure into an extremely narrow corridor. That creates a different problem: cumulative coordination. Every section has to connect to the next one. Foundations must work with local ground conditions. Structural loads have to travel safely into the soil. Expansion joints and movement systems have to accommodate temperature changes. Utilities have to remain accessible. Transportation has to continue through the entire system. And the desert doesn't become easier simply because the architecture is futuristic. Here's the thing about the line that every structural engineer knows: the taller and more continuous a structure becomes, the more important movement becomes. Tall buildings sway in wind. That isn't a defect. It's normal behavior. But the line isn't one ordinary tower. Its early construction has already required an enormous foundation operation. Reporting on the hidden marina section described modules supported by more than 5,500 piles each, with some piles reaching roughly 70 meters deep. A pile is simply a long structural element driven or drilled into the ground to transfer a building's weight into stronger soil or rock below. Not slightly. Not as a design flourish. At this scale, the foundation is an industrial operation by itself. And this is where the project becomes genuinely interesting. The engineering response has been to divide the enormous concept into modules and phases rather than attempt to construct 170 kilometers as one continuous operation. Reports have described the line as consisting of 135 modules, each around 800 meters long and 500 meters tall at sea level. At the hidden marina, foundation work has involved thousands of piles, massive excavation, and large concrete volumes. One 2025 geotechnical report recorded ultrasonic testing of three 1,500mm diameter bored piles to check concrete quality without destroying the foundations. That part doesn't make it into the architecture magazines. The boring work is the real story. There are also different pile technologies being tested. Kelpraise Hyper system used 1.2-meter diameter precast concrete piles assembled in 10-meter segments to create piles around 50 meters deep, with testing to a 50 meganewton compression load. The point isn't that the foundations are failing. The point is that a project this unusual requires construction methods unusual enough to test and refine while the city is still being designed. But here's something about this building that nobody ever explains. A city is not just steel and concrete. People need water pressure on upper levels. Wastewater has to leave the structure. Air conditioning systems have to operate in one of the hottest environments on Earth. Elevators have to move enormous numbers of people. Fire systems have to work. Doors have to align. Glass has to accommodate movement and temperature. Maintenance crews need access to equipment buried behind walls and ceilings. Now multiply those ordinary problems across 170 kilometers. A swimming pool doesn't care that the master plan looks beautiful. A toilet doesn't care about artificial intelligence. A lift doesn't care about the rendering. They simply have to work. And this part barely gets mentioned anywhere. The project also sits in an environment where logistics matter enormously. Early construction has involved major excavation, concrete production, piling, roads and worker infrastructure before a conventional city even exists. But here's the detail nobody surfaces. The line's schedule changed dramatically before the physical vision had come close to completion. On April 5, 2024, Bloomberg reported that Saudi officials had reduced their expectation for the line's 2030 population from around 1.5 million to fewer than 300,000, while only 2.4 kilometers of the planned 170 kilometers was then expected to be completed by 2030. Within days, the story changed from how quickly the city could transform Saudi Arabia to how much of the original target could realistically be delivered. Within months, Reuters reported that NEOM was prioritizing parts of the wider program connected to major sporting deadlines as costs increased and schedules tightened. Nobody was hurt. There was no dramatic structural failure. The incident was a schedule failure, and those can be quieter. The Burj Khalifa proved that a building could push height beyond anything previously constructed at that scale. The Shanghai Tower demonstrated how aerodynamic shaping and structural systems could control wind effects in a super tall tower. The Channel Tunnel proved that massive infrastructure could be completed through difficult geology and international coordination. The line is different. Here is the fundamental difference between the line and every other mega project we've covered. Those projects solve a defined engineering problem. The line is trying to solve an entire city's problems inside one physical system. And that makes time itself part of the engineering challenge. Here's the question that sits beneath all of this. What happens when a city is designed for a future population that hasn't arrived yet? The line's original concept envisioned 9 million residents. NEOM still presents that long-term figure, but the 2030 expectations reported in 2024 were dramatically smaller. The difference isn't cosmetic. Concrete can be tested. Steel can be inspected. A pile can be scanned. But demand is harder to engineer. You can calculate the load from a building. You can't calculate with the same certainty how many people will actually want to live there in 2045. Think about what that means for a city built around extreme density. A system designed for 9 million people has to make economic sense before 9 million people arrive. Transport, utilities, retail, schools, hospitals, hotels, and public spaces all depend on population. If the population arrives slowly, the economics change. If construction slows, the population target changes again. It becomes a loop. Build for the people who aren't there yet, or wait for the people before building for them. There is no historical data for what a 170-kilometer linear city looks like at 50 years, because number 170-kilometer linear city is 50 years old. This is the first. It is the only one. So engineers in 2076 won't simply inherit a finished landmark. They'll inherit decades of inspection data from foundations, joints, facades, mechanical systems, transport infrastructure, and utilities, and they'll be able to compare what the original calculations predicted with what the real structure actually did. That data doesn't exist yet. And honestly, that's a little unsettling. Not because the structure is known to be unsafe. Because nobody can inspect the future. Today, though, the human reality is much simpler. A worker can stand beside a foundation pile and hear drilling equipment cutting into the ground. Concrete arrives. Steel reinforcement disappears below the surface. Surveyors check positions to millimeter-level tolerances. Somewhere nearby, someone is eating lunch in the heat while a project that was once presented as a 170-kilometer city is being built one controlled section at a time. The strange thing is how ordinary the work can feel. A massive machine moves soil. A pump pushes concrete. A worker checks a measurement. Dust settles on boots. The future, apparently, still needs paperwork. But here's something about this building that nobody ever explains. The line hasn't disappeared. Construction and planning have continued, while the scale and priorities have been reassessed. What has changed is the distance between the original promise and what can realistically be delivered on the original schedule. None of them are thinking about the 9 million people who were supposed to live here. They're thinking about today's poor. Right now, somewhere in northwest Saudi Arabia, a person can be working on the physical beginnings of a city that may eventually become one of the most ambitious urban experiments ever attempted. They may not know what the final version will look like. And that's the question nobody asked at the beginning. Not whether it could be designed. Whether it could be delivered at the scale promised. Drop it below. Would you actually live inside the line if it were completed as originally planned? See you in the next one. Verify. NEOM announced in 2017 as part of Saudi Arabia's Vision 2030 transformation program. The line was announced as a 170-kilometer long linear city. The line is planned at 500 meters high and 200 meters wide. NEOM states a long-term capacity of up to 9 million residents. NEOM states a footprint of 34 square kilometers and preservation of 95% of surrounding land. Parsons lists the line's estimated project value at 100 to 200 billion US dollars. NEOM is owned by Saudi Arabia's Public Investment Fund. Delugan Meisel Associated Architects, Gensler and Mott MacDonald were appointed for first phase urban design, planning and infrastructure design in November 2024. Atkins was appointed as a delivery partner in February 2023. Atkins, Realis, Jacobs, and Parsons are identified as delivery partners in reporting on the line. The line's planned modules have been described as 135 modules, approximately 800 meters long and 500 meters tall. Hidden marina modules have been reported as supported by more than 5,500 piles each, with some piles reaching about 70 meters deep. A 2025 pile testing report recorded testing of three 1,500 mm diameter board piles using cross-hole sonic logging. Kelpray's hyperpile system used 1.2 meter diameter precast concrete piles, assembled in 10 meter segments, forming piles about 50 meters deep and tested to 50 kilonewtons compression loading. Bloomberg reported on April 5, 2024 that the expected 2030 population had been reduced from approximately 1.5 million to fewer than 300,000. Bloomberg also reported that approximately 2.4 kilometers of the line was expected to be completed by 2030 under the revised target. Reuters reported in November 2024 that NEOM had prioritized parts of its program connected to major sporting events amid rising costs and delays. The statement that tall buildings sway in wind is established structural engineering behavior. Sway itself does not indicate structural failure. No claim is made in this script that the line is structurally failing or at risk of collapse.